So in this part, we are going to discuss about another component in microservices landscape called as API gateway. So this is how our present architecture looks like, right? Like if the user wants to access the product service, we are now calling some arbitrary port where the product service is running on. So we're making a call to localhost some random port /API/product to access the product service. Similarly, to access the order service, we are calling another port and calling the request and making a request to /API/order. This is fine for a dev environment, but on a productive environment, this will not work, right? As we have already discussed before, the microservices environment can have multiple instances and the application can run on different ports also, right? So for this reason, we cannot rely on hard coding these values when we want to call the services. So the solution for this is to introduce a component at the start of our architecture landscape called as a API gateway, which is responsible to route the request from users to the corresponding services. So let me scroll down, and yeah, this is how it looks like. So we will have an API gateway which acts like an entry point into our system landscape, right? And if the user wants to call the product service, the user just calls the normal API gateway with the normal URL, like it can be onlineshop.com, right? And to be able to call the product service, all we have to do is call onlineshop.com /API/product. And then in our API gateway, we can configure the rules such that if we receive a request with the URL parameter as /API/product, then route it to product service. And if the user wants to call the order service, based on the request URL as /API/order, we can route this to order service. And also similarly, if you want to access a discovery server behind the API gateway, we can also configure a rule such that if it contains /Eureka in the URL, then please route this request to the discovery server, right? So this API gateway will, as the name suggests, acts like a gatekeeper to whatever requests which the user wants to make to our services. So not only that, it can also address some additional cross-cutting concerns in the microservice landscape, like authentication. So if you want to make sure that all the requests are authenticated, we can configure that in API gateway. So what API gateway can do is it can contact the authorization server or whatever authentication mechanism you want to implement. So it can also take care of authentication and security. So that's how we're also going to implement in this project. We will make our API gateway talk to the Keycloak authorization server and will implement the security aspects. Apart from that, it can also act as a load balancer. So if we have multiple instances of product service and if the user makes a request to the product service, it will make sure which instance of the product service to call, and it will retrieve the response from that instance and send it back to the user, right? Apart from that, it also tries to implement the Ssl termination. So usually if you are making a call to any external service, sure to include the HTTPS scheme there by following the TLS protocol. So if we call the API gateway from the outside with the TLS scheme with HTTPS protocol, the API gateway, as it's already part of the microservices network, right? We don't need HTTPS here as this is completely internal communication. So we can just perform HTTP communication without HTTPS. So that's why usually the SSL connection will be terminated at the time of at the entry point of the request, right? So this will be terminated at the API gateway level. This is also implemented for us automatically by all the API gateways. So in the market, we have different kinds of API gateways. We have one popular API gateway called as APG, and the one is a Kong API gateway. But in this project, we are going to make use of Spring Cloud's own implementation of API gateway called as Spring Cloud Gateway. So now let's go ahead and have a look at how we can implement the API gateway in our project. To understand more details about Spring Cloud Gateway, I'm going to open the Spring Cloud documentation by opening the spring.io project Spring Cloud URL. And in here, I'm going to search for Spring Cloud Gateway. And you can read more about what is Spring Cloud Gateway here. And here, these are some features listed for the Spring Cloud Gateway. It's built on Spring Framework 5, Project Reactor, and Spring Boot 2. So this is a very important thing. It's not built on top of Spring Web MVC, but it's built on top of Spring Web Flux, which is built on top of Project Reactor. And we also have different features to be able to match routes on any request attribute, predicates and filters, which are specific to routes, circuit breaker integration. We will have a look at it in the coming parts. We can also have integration with the Spring Cloud Discovery client, and we can also have the support for request rate limiting and URL path rewriting. Right, we can have a look at some of these features in this tutorial. So to get started, I'm going to open start.spring.io website, and we need to first get some dependency information. So once we get this information, we can create the API gateway for ourselves. So for that, I'm just going to click on add dependencies, and I'm going to search for gateway. So I'm going to select this dependency, I'm going to click on explore, look for the pom.xml, and here I'm going to just copy the dependency information here called as Spring Cloud Starter Gateway. Just make sure to copy this, and now I'm going to open my IntelliJ IDE, and what I'm going to do is I'm going to create a new Maven module under the root Maven project. So I'm going to click on new module and make sure to select the option Maven here and click on next, and I'm going to call this project, this Maven module, as API gateway. Click on finish, and now inside the pom.xml of API gateway, I'm going to add a new line, and I'm going to type in dependencies, and I'm going to paste in the dependency information from which I copied from the start.spring.io website. I'm going to force Maven to download these dependencies. So for that, I'm just going to click on this load Maven changes button. So IntelliJ will take some time to download the dependencies. So once this is completed, I'm going to open the API gateway folder. So go to source main Java, and I'm going to create first of all a new package called as com programming techie .api gateway, and I'm also going to create a new class called as API gateway application. So this is going to be a Spring Boot application, and I'm going to again add the public static void main method by typing spring application.run. I'm going to pass in the API gateway application.class name, and finally I'm going to provide the arguments here. So we have added the dependency for API gateway, we have configured the main application class, and the next thing we are going to do here is to add the dependency for the discovery client, right? Because as our API gateway is also one of the component inside the microservice landscape, it also register the API gateway as a discovery client, right? So for that, I'm going to just go open the pom.xml of product service, and I'm just going to copy the dependency information of the Spring Cloud Starter Netflix Eureka client, and I'm going to paste it inside the pom.xml of API gateway, and make sure to again reload the Maven changes by clicking on the Maven icon. And now I'm going back to the API gateway application, and I'm going to enable Eureka client annotation so that the Eureka client features will be activated inside our API gateway. And after that, what I have to do is I'm going to create a new file inside the resources folder called as application.properties. Alright, so in this application.properties file, so first of all, I'm going to define the Eureka server URL by typing eureka.client.service URL default zone equals http localhost 8761/Eureka, right? So this is the service URL for the Eureka server, so that the API gateway can make a call to this particular URL and register itself as a discovery client, right? And after that, I'm going to type in the spring.application.name property as API gateway. Just to have some additional information, I'm going to increase the logging level of the API gateway application. So I'm going to add logging.level.root is equal to info, and I'm going to type in logging.level.org.spring spring framework.cloud.gateway.route definition locator. So this is the class which is responsible to define the routes and also identify the routes for the incoming requests. So I'm going to put this logging level information as info, and finally I'm just going to copy all the information here until the cloud.gateway, and for the cloud.gateway package I'm going to define the logging level as trace. Right, so by adding this information we are going to have some more logs, and we can understand what is going on behind the scenes whenever a request is made to the API gateway. Right, and after this configuration, all we have to do now is define the routes. So if I open our architecture diagram one more time, whenever the user wants to make a call to the product service, we can make sure we can understand that it should go to the product service by inspecting the URL. Right, so if the URL contains /API/product, then we have to route it to product service. Similarly, if the URL contains /API/order, we have to route it to the order service. Right, we have doing this based on some certain rules. So we can define these rules inside API gateway as routes. Right, if I open the documentation of Spring Cloud Gateway on the learn, and by opening the reference documentation, you can read about Spring Cloud Gateway in much more detail of what I can cover in this tutorial. The glossary section, here you can see how everything works. We have routes, which is like a building block of gateway. So each URL we want to route through the API gateway, we will create a corresponding route. And we can have a predicate as well as a filter. Like a predicate lets you define the matching criteria for all the HTTP requests. And lastly, we also have filters where you can modify the requests which are coming into coming into the API gateway. So we can modify the request as well as the response. That means you can add additional URL parameters, and you can also add some additional headers to the response when we are trying to process the request and response information. So now what we are going to do is we are going to define a route inside our project. So I can define a route. So here what I want to do is I want to define a route for the product service. So I'm going to type a comment called as product service route, and to define the route I'm going to type in spring.cloud.gateway.routes. We can define some list of routes here. So I'm going to create a number of multiple routes. So for that I'm just going to add the index as 0, and for each route I can define an ID. Right, so ID is going to be product service. Usually it would be the name of the application, name of the service which we are defining. And after the ID, we can also define the URI which we want to map to this particular service. So for this going to be HTTP product service. API gateway also acts like a load balancer. We can also ask API gateway to load balance this request by typing LB. So in this way, the API gateway will also do some client-side load balancing, and it will try to access the available instance of the product service. Right, and after this, lastly, we are going to define the URL parameter which should match this particular service. So for that, I'm going to type in Spring Cloud Gateway.routes of 0 dot predicates. So we can pass multiple predicates to the route. So we're going to define only one predicate. This predicate is going to be a predicate of type path. Right, and so I'm going to type path equals /API/product. So whenever we receive a request with path predicate as /API/product, then our API gateway will route this particular request to the product service. So this is what this actual 3 lines means. So in this way, we can also define multiple routes we can also define the route for our order service. So for that, I'm just going to copy this whole information one more time. I'm going to paste this and rename the product service route to order service route. And this is a second route we are defining inside our application properties file. So I'm going to change the index 0 to 1. And I'm going to change the ID from product service to order service. Also going to change the URL from our product service to order service, And lastly, I'm also going to change the path from /API/product to /API/order. So if you want to know more information about the kind of predicates we have, you can refer to the documentation section inside the Spring Cloud Gateway. So if I open the route predicate factories section, you can see different kinds of routes. So we can define an after predicate, a before predicate. We can define a predicate based on the cookie if it contains some attribute inside a cookie, and we can also define a predicate based on the method. So if you want to just handle the post request for a particular service, you can also define the predicate as a method here. And we have the path predicate where we have used, so based on the URL path we are defining the routing scheme. So we have different kinds of routes, so just make sure to check this documentation section if you want to do something differently. So now what I'm going to do is I'm going to open the API Gateway application, and let's try to run our API Gateway application. Alright, so we are getting an error whenever when starting up the API Gateway application. It says web server failed to start, port 8080 was already in use. So we are running the product service application on port 8080, and the API Gateway application also uses port 8080 by default. So what I'm going to do now is change the port of the product service. So for that I'm going to open the application.properties file, and in here I'm going to type in server.port equals 0 so that it will take a random port available to the machine. So I'm going to restart the product service, rerun in debug mode, and also start the application API Gateway application one more time in the debug mode. So now you can see that the product service application is started on port 61795, and the API Gateway application is able to start successfully on the port 8080. And now let's open our Eureka server and check whether we are able to see this API Gateway in the dashboard or not. So open the Eureka server, localhost 8761, and I'm going to refresh the dashboard, and you can see the API Gateway is registered in our Eureka server as a client. So that's perfect. So what I'm going to do now is make a request to the product service through the API Gateway. So for that I'm going to type in http localhost 8080/API/product, and I'm going to make a GET request. So I'm just going to click on send, and you can see that we are receiving the response back from the product service. So it's not like the product service is running on port 8080, it's running on port 61795. So let's test whether the product service is really running on the 61795 port or not. So I'm just going to copy this URL, create a new tab, and change the port from 61795 from 8080 to 61795, and make a request one more time, and you can see that we are still getting the response. So that means the request went through to the API Gateway and reached the product service. So we can also verify this inside the logs. So I'm going to open the logs and of the API Gateway application, and if you just scroll down, you can see some detailed information about the logs. So we can see that the pattern API/product matches against value API product, that means which is defined for the product service. And you can see that in the log says the route matched is for product service. It's trying to make a GET call to this product service. You can see much more information about the logs, how it is matched, how the routes are matched, and you can get a good good idea of how the API Gateway is working behind the scenes by enabling the logs, right? So let's also test whether the API Gateway is working fine for the order service or not. So I'm going to open a new tab, change the post method to change the HTTP method to post, and I'm going to type in HTTP localhost 8080/API/order, and I'm going to just paste the request body which I've used before. And now I'm going to click on send, and you can see that we received the response order placed successfully. So I'm going to open the API Gateway one more time, and here you can see that we see the logs that a route is matched for the order service, and it's trying to make a post call to the /API/order endpoint. So in this way we can define the routes inside the API gateway. So in the next section, what we are going to do is we are going to also access the Eureka server. So to access the Eureka server, right now we are going to the localhost 8761 port. So what I'm going to do now is also try to access the Eureka server through the API gateway, right? So for that, what I can do is I can open the application.properties file of API gateway, and I can define another route for the discovery server. So I'm going to copy this route information one more time and change the comment as discovery server route, and the ID I'm going to define as discovery server. And for the discovery server, I'm going to define the URL as localhost 8761, and the path is going to be not /API/order, but I'm going to access the Eureka server in a path /Eureka/web, right? As of now, we are calling 8761 without any additional URL parameters. So what I'm going to do now is I want to access Eureka server at http localhost 8080/Eureka/web. Right? Whenever I call this particular URL, I want my request to be routed to the Eureka server, right? So that's why I added the path predicate as /Eureka/web. I'm going to also change the index to 2 instead of 1, right? So now I'm going to restart the API gateway application. So I'm going to now rerun API gateway application, and so our API gateway is restarted successfully. So now I'm going to open the browser, and now I'm going to type in localhost 8080/Eureka/web, and I'm going to, if I press enter, we are getting a 503 error. This is because what our API gateway is trying to do is it's trying to call localhost 8761/Eureka/web, but there is no route in the Eureka server for the path Eureka/Eureka/web, right? So what the API gateway is trying to do is it's trying to pass in these URL parameters also to the Eureka server, right? As there is no route for Eureka server for this Eureka/web, we are getting a 503 error, right? So what our API gateway should ideally do is whenever it receives a request at localhost 8080/Eureka/web, it should call the Eureka server at localhost 8761, right? It should make a call without the URL parameters, right? So how can we do that? So previously I mentioned that we can modify the requests in our API gateway with the use of filters, right? So we can make use of filters to actually remove the URL parameter, and you can change the path of our request, right? So let's do that. I'm going to open the application.properties one more time. So what I'm going to do is I'm going to define a filter for this particular route. So for that I'm going to type in Spring Cloud Gateway .routes of 2 .filters. So I'm going to define a filter. So this filter is going to be called as set path, and the set path, as the name suggests, it will try to change the path of the URL request, so path of the URL. So instead of /Eureka/web, I'm going to define the URL path as just /, right? So whenever we make a call to the API gateway with /Eureka/web, it will just forward this request to HTTP localhost 8761 without any URL parameters. So after we have defined this filter, I'm going to again restart the application. So after the application gateway, after the API gateway is restarted, I'm going to open the browser one more time, and now I'm going to type in /8080/Eureka/web. Okay, so we are still getting the 503 error. So let's open the logs and check what may be the reason here. So if you see that we have, so if you observe the logs, that the discovery server route definition is matched successfully, but you can see that inside the round robin load balancer class, it says that no servers available for service localhost, right? Because as we only have one instance of the discovery server, it's not able to actually load balance the request to the discovery server, guys, because as you have defined the text LB, we wanted to also load balance the request to the discovery server. This is not working as there is only one instance. So here what I can do is, instead of putting LB, I can put it back as HTTP, and let's try to check if it is working fine or not. So I'm just going to restart the API gateway one more time, rerun in the debug mode, and let's now test whether this is working fine or not. So now if I open the browser and go to localhost 8080/Eureka/web, you can see that we are able to access the Eureka server through the API gateway, but we are getting a plain HTML instead of the CSS and the other static resources, because we defined the route only for the Eureka server but not the static web resources, right? It should not only load the HTML but also some other static resources like CSS and JavaScript files. So for that we have to define another route for the Eureka server just for the static resources, right? So what I'm going to do is I'm going to copy this route one more time, and I'm going to define this route as discovery server static resources route, right? So I'm going to change the index from 2 to 3 and change the ID as discovery server static. And here I don't need the filter anymore, but instead of the path /Eureka/web, what I can do is I can just add double stars. So whatever request which is made from the path /Eureka/star, it will be routed to the discovery server. So whatever request we make on the path /Eureka/star, it will be routed to the discovery server, right? So I'm just going to again restart the API gateway application, and once the API gateway is up and running, I'm going to open the web browser one more time and I'm going to refresh, and now you can see that the CSS is able to load successfully, and we are able to access also the discovery server through the API gateway. That's it from this tutorial, guys, and in the next part we are going to secure our microservices by using Keycloak. So we are going to implement the security through the API gateway. So I will see you in the next video. Until then, happy coding, techies.